So, just straight up the last 7 days have been an exponentially increasing dumpster fire. How far did the video from yesterday go through again? Did you get to Gauss Jordan, or was it just Gaussian elimination by matrix? So you got to elimination with matrix, you got to Z, and then you came out of the matrix, right? So you would just eliminate.
Make sure you log into Moodle and your class, not student body, your class. So on your link to your class graduation year,
So you got to this and then come out of matrix. Okay, so do that instead, not full Gauss Jordan. Just do this by row operations in matrix. Y'all, today makes 0 sense if you didn't actually do what you were supposed to yesterday. Let's go.
next week, Wednesday, Thursday, Friday. Sure you can have your app. We'll run your app to this. We can check that out. Teachers and students, please go through those apps now and make sure. Maybe cross-country meeting, auxiliary gym, Friday morning at 7:45. All students and the rest of the cross-country next year, auxiliary gym, 7:45. Friday morning, you'll discuss summer training and schedule. Always have a do the what?
That's facts. I'm moving to. So I can actually see.
One gone, Y5. Y by 2. Gone by 2. 1 by 2. 1. So negative 1. Negative 1, 1. For those of you that actually did stuff yesterday, this is one of those magical Christmas lands where you get a double elimination right away. By the way, that 3 Milks cake was freaking weird. It had a puddle at the bottom. Like, that's why it's called Tres Leches, 3 Milks. It's condensed milk, powdered milk, and then regular milk in the recipe. But it had a puddle at the bottom after you start eating it. Now it's just the leech. Do we need more? Still rolling? Got it? Okay. Yep, doesn't happen all the time, but when it does, it's pretty nice. As y'all are finishing up, just let you know, like the last week, obviously, I have, it's hard to describe the last week without the word cluster. Rapid onset of symptoms on Wednesday. I ended up puking from the 3rd hour, like fevered hallucinations all the way through Thursday. Friday, I white knuckled it all of Friday. Went home and passed out by 7:30. And then this weekend, my wife went down. Same thing, super, super fast. That's why I had to leave on Monday. So 3rd hour has just legitimately not had me in class teaching for like a week and a half. So I really do. I feel bad for them. I apologize for that. And then now we've got follow-up appointments and stuff. So got a doctor's appointment this afternoon, so I'm going to miss 3rd hour again. My wife has a follow-up tomorrow afternoon, so I'm going to miss my 4th hour. Like, it is just chaos. Get a call last night, Grandpa's in the hospital. Grandpa's basically my dad. I don't know if I might disappear again for like finals. I'm just giving you all a heads up that it's all coming at once and it sucks. And thank you for putting up with the mess. Okay, I will reward you with donuts at some point. So, the premise of the beginning of 6.1 was just like with synthetic division, you can remove all the alphabet soup when you're doing systems. And the bigger the systems get, the more you're going to need to do that. We're primarily going to work with 3 variable systems that have 3 equations. But today, I am going to show you 4 variable. I am going to show you 4 equations. Same process, okay? But if we're going to deal with that much raw information, we need a better way to organize our thoughts. Instead of just taking up a page and a half of math everywhere. Alphabet soup puked on your paper, right? So we come up with matrices. Matrices are like tables for numbers or for equations, where I understand that this is the X, Y, Z, and answer column. This is equation 1, 2, and 3. So I just remove all of the alphabet soup and I got myself a matrix. We're going to call it 1, -1, 1, 3. -1, 2, -1, 2, 2, -3, 3, 8. If you want to put like a little divider line here, so you differentiate between your coefficient matrix and your answer matrix, that's okay. It's not necessary. And every step along the way, you are looking at the previous matrix, the previous problem set defines what row 1, row 2, and row 3 are. And you write your directions next to it so that anyone can follow what you did arithmetically. So the goal of Gaussian elimination is to get rid of this triangle of values. Because if I do, then I'll have this many z's equals this much number. If I know what z is, then I can go up to the next one, find y, take those up to the next one, find x. Okay, it kind of dominoes its way through the problem. And the easiest way to do that is if I got a 1 or a -1 up in that top left corner, I call it the command zone. Okay, if you got a 1 or a -1 up there, easiest problem in the world. Because 1 times anything is anything that I'm looking for. So I'm going to get rid of these two right here by saying this is row 1, row 2, row 3. So I'm going to say row 2 plus row 1. And then get my mental math on. 1 plus -1 is 0. -1 plus 2 is 1. 1 plus -1 is 0. That's what I meant by double elimination. 3 plus 2 is 5. Because now this line says 1y equals 5. I just straight up have answer there. Now, I want to use my space as much as possible, so I don't just want to do one operation. I'm also going to try to get rid of this guy. Do you want to use row 1 or row 2 to get rid of that 2? Okay, I could say row 3 minus 2 row 1s. I could also say row 3 plus 2 row 2s. And you get a choice. Personally, I am always going to go for the choice that doesn't involve me throwing a negative into my work. Because that's one more thing for me to goof up. I'm going to say row 3 plus 2 row 2s, because then I don't have to mess with negatives. That's me, doesn't have to be you. And that's what we're going to see today is there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19. At least 20 ways to start every one of these problems. Okay? I had one question asked yesterday, and it was, do I have to do it in this order? And the answer is right now, yes. Because there's an algorithm to it if you don't want to think. That's the way that the book solutions are going to be written. But after today, you can be smart enough to work within the matrix however you need to. There is no spoon. You get to bend reality to whatever you want it to be. 2 of these plus that. Bye-bye. 2 of these is 4. Add it here. 1. 2 of these is -2. Add it here. 1. 2 of these is 4. Add it here. 12. And I can't really go messing with anything in row 1 without getting rid of that 1 up in that top right corner, or left corner, that I want. So I'm just going to leave that one alone and say 1, -1, 1, 3. So I'm almost there. If I want to eliminate that triangle of values, that's what Gauss said. Okay. Gauss says I want this triangle of values gone so that I find out what z is. I only need to do one more thing. I'm going to use this guy to get rid of him. I do that very quickly by just saying row 3 minus row 2. Keep in mind, I'm not looking up here anymore. I'm not looking at this. This is my row 3 now. This is my row 2 now. This is my row 1 now. I am the captain now. Okay? So I say 0 minus 0 is still 0. 1 minus 1 is 0. 1 minus 0 is 1. 12 minus 5 is 7. And then I'm not going to touch any of the other stuff. Because this now says, right here, 1z equals 7. Get back here. This now says 1y equals 5. Now normally there'd be a number here and I'd have to plug z in to solve for it. But we had double elimination magical Christmas land. And if I have those, I can go back to the very, very beginning and say that's 1x minus a y plus a z equal to 3. Plug in z, plug in y. Here I get a 2, subtract 2 to the other side, get x is uno. And then I write my answer as a 3-dimensional coordinate, 1, 5, 7. Okay? What we're going to be doing for this entire section, because really the math is math, but you have the freedom within matrices to do whatever you want, to do it in the order you want, so long as you follow math law. It's kind of like when you finally get your license and you just say, I'm going to go over to so-and-so's house and your parents don't care. For the first time ever, you have the freedom to decide what you're going to do, right? You want to go stop at Dairy Queen first? You want to pit stop at Walmart? Are you going to go over to this person's house instead? Are you going to lie to your parents and go all the way to Rapid? Like, you have choices now. So I'm going to say each one of these is going to be on Likert scale. It's still out of 5 points. But that 5 is now, I got all the way to the end zone. I got the work to back it up. I literally made one tiny error. I see exactly where it is. I know what I did. It's right there. Everything else is cool. I made 2 or 3 little mechanical errors. Like, I forgot to double these last 2 numbers when I added. And then I missed a negative down here. But you see where the problem is. You didn't even finish the problem. Or you went so far down a rabbit hole and you don't even know where you went wrong. It's just a giant mess. You attempted something that looks like a matrix. You didn't even do that. You wrote down the problem and you stared at it. Okay? So we're going to be doing a lot of this Likert scale stuff with this chapter. All right. Then go away. Let's get back up here. Boop. So you would have done regular systems, triangular form, writing your matrices, what row echelon form looks like. You did it or didn't do it? Did do this one. And this one, remember, you ended up with not enough information? Okay. So, over the years, there's a lot of mathematicians that will work on top of each other's work. Sometimes they'll even steal it. You ever hear like Newton invented calculus? He didn't. He stole it from Leibniz. Leibniz came up with it before. Newton was kind of on the same track. Leibniz died after he sent his stuff to Newton to, like, you know, peer review, and then Newton just took credit for it. Kind of shady. Well, along comes this guy Jordan, and he says, you know, if I just keep going in the matrix, like, you know, at the end, it's 0, 0, 1, I have answer for Z. Well, if I just keep going with that, couldn't I say this is the answer for Y, this is the answer for X? And just straight up have, here's my answers. So all Jordan figured out was, why don't I just keep going? And he gets what's called reduced row echelon form. Remember, row echelon form says, I want to eliminate that triangle of values. And then if there's ever a row that ends up all zeros, you know, it's always going to be at the bottom because it doesn't do anything. Well, say these are still numbers. Jordan comes along and says, you know, I got a 1 down here in the bottom right corner, a lot like I started with a 1 in the top left corner. If I can use this to knock these two out, then I can use this to knock these two out. Wait a second, this is just the same thing, I just keep going. And he creates Gauss-Jordan elimination, which says, I'm going to, step 1, I'm going to knock these two out. Step 2, I'm going to knock this guy out. Now I'm going to have Z, I'm going to keep going. I'm going to use that bottom right corner to eliminate the two Z values above it. And then finally, the only thing that I'll have left is, now this will be gone and this will be gone. So now I'll have this value with zeros to either side of it. So now I'll use this to eliminate the very last value. And I'll get 1s on the diagonal and an answer matrix. Okay, so step 1, 2, 3, 4. What I'm going to tell you is you can do this in 3 steps if you're willing to work with fractions or large numbers and combine steps 2 and 4 at the same time. Okay, every single 3-variable matrix we're going to touch, you can do it in 3 steps if you're willing to go to fraction town or big number town. If you hate that, then it might be 4 or 5 steps. Okay? And there's nothing wrong with that. I have seen kids who just despise all of this extra stuff, and they want to multiply this row and then rewrite the matrix. Now add the rows, write the matrix. They want to do it piece by piece by piece by piece. It might take them 9 steps. Okay, you still got there. I'm telling you, you can do them in 3. And if you put those steps in order, what it effectively is I will start here and I will eliminate them in that order. I'll just go around, okay? So it all boils down to, if you can get a 1 in that top left corner, it makes it easier. It's not necessary, but it's definitely easier. Okay. Show you. Step 1, you got to write your matrix. So we're going to have 1, -1, 1, 0, -1, 2, -3, -5, 2, -3, 5, 8. Okay. I write my matrix. Come on, Frank. Yeah, we'll do there. So, step one. I got a 1 in that top left corner. That makes life way easier because I can use that to eliminate both of these two x values below it. I can say row 1 plus row 2. 1 plus negative 1 is 0. Negative 1 plus 2 is 1. 1 plus negative 3 is negative 2. 0 plus negative 5 is negative 5. How do you want to get rid of that 2? Use row 1 or row 2. I don't care. But I just want to hear what the instruction sounds like that I write next to it. Row 3 plus 2 row 2s. Does that work? Yep, it does. Right? 2 of these is negative 2. If I add it here, 0. Okay. So 2 of these added to 2 is bye-bye. 2 of these, 4, plus negative 3 is 1. 2 of these is negative 6. Add it here, it's negative 1. 2 of these is negative 10. Add it here, negative 2. Now, I can go messing around with row 1 if I want. I'm not going to right now because that might be a little overkill as we're just learning Gauss-Jordan. Do you have the triangle eliminated yet? We always start with the triangle. So I move on to round 2. Now, luckily I do have a 1 right here. Makes it very easy to eliminate that next value for the triangles. I'm going to come back and show you where you could double dip here, but I'm not going to do it right now because some of us are going to need this around the world thing. Some of us are going to just have to follow that pattern every time. So I'm going to start with that, then I'll come back and show you a little more sauce. Okay, how do I write the directions? How do I say I'm getting rid of this? Row 3 minus row 2. Because 0 minus 0 is still 0. 1 minus 1 is now 0. Negative 1 minus a negative 2. Watch your signs. Is 1. Negative 2 minus a negative 5. 3. 0, 1, negative 2. 1, negative 1, 1, 0. Okay. So this is Gaussian elimination. This is where we left off yesterday. Jordan comes along and says, you know, I don't want to come out of the matrix yet. Okay? Like back in 1992, Cypher saying, no, I want to take the blue pill. Okay? I'm going to take 1 and use it to knock out the z values above it. Because, see these zeros here, if I use row 3 to attack rows 2 and 1, I ain't going to touch anything up there because zeros don't affect anything. 0 plus number is still 0. 0 times number is still 0. I have the freedom to do that now without affecting the work I've already done. So, how do I get rid of this guy? Use row 3. Yeah. I'm going to use row 2 plus 2 of those row 3s. Because now, take this times 2 and add it, it's still 0. This times 2 and add it, it's still 1. This times 2 and add it, it's gone. This times 2, 6, and add it, 1. I don't want to touch this row. It's already done. While I'm here, how could I get rid of that guy? That top right one. Using row 3. Just subtract it. Row 1 minus row 3. Because 1 minus 0 is still 1. Negative 1 minus 0 is still negative 1. 1 minus 1 is bye-bye. And 0 minus 3 is negative 3. You see how it's almost there, right?
You just like make it not a -1 by messing with row 1 minus row 3, so you get positive 1.
I could, but now I'd have a negative 1 here.
I don't understand why you do this. If you know this, you work back and make sure everyone's.
Don't have no
Because I can go directly to the answer in an organized fashion when I start hitting 4, 5, 6, and 7 variable systems. Hint, hint, section 6.4, partial fractions. All right. Do you see how I can finish this off, though? What that last step is? I now can take this to knock out my very last value and say row 1 plus row 2. 1 plus 0 is 1. Negative 1 plus 1 is 0. 0 plus 0 is 0. Negative 3 plus 1 is negative 2. Don't touch the others. And Holly wants to take the beads inside the little squishy toy out of the toy to play with them. I would rather leave them inside the toy to just play. Holly wants to make a mess. Where'd my shark go? There we go. All right. Dinosaur. Okay. I want to leave everything inside and play with it like this, where it's contained and organized. If I come out of the matrix at green, that would be like ripping this dude's head off and dumping the beads out so I can play with them. Okay? Yes, you can do that, but we've lost our organization. And the organization is what's important for later when these get nasty. Because look what I now have. I have 1x equals negative 2. 1y equals 1. 1z equals 3. That's just straight up my answer. Negative 2, 1, 3. Now, this was 4 steps, right? I said you can do all of them in 3 steps. If I back up to all the way to blue. So the first thing we did was eliminate those. What I can also do is eliminate this guy. I can say row 1 plus row 2 right now, because this 0 will not affect the one above it. I'll get 1, 0, negative 1, negative 5. Leave the middle row alone and say row 3 minus row 2. We had 0, 0, 1, and 3. You see how now there's only 1 step left? instead. Now I can use this to batter those two out of the way because there's already a 0 up here for me. It makes it shorter and faster. Okay, now I can say row 1 plus row 3, row 2 plus 2 row 3s. Because row 1 plus row 3, 0 and 1 is still 1, 0 and 0 is still 0, 1 and -1 is 0, 3 and -5 is -2. Still get a 0, still have a 1, now it's a 0, now it's a 1. Leave the bottom row alone. Because now I've got my 1s on the diagonal, everything else is 0s. Now you're able to do it in 3 steps. Wham, bam, bam. Done. Okay? And we did it by 2 different methods. Number 1 is to knock out these, knock out this, knock out those 2, then come back and do this guy. This is going to be more difficult as the numbers inside there get bigger and nastier. Right now we're dealing with fairly small, nice numbers. We got a 1 up in the command zone. Everything's great. But as things move along, come on, Frank. Come on, Frank. You can do it. It might be better to stick with instead this. Eliminate them in that order. Okay? Because if you do them in that order every single time, you don't have to think. It will be 4 steps every time, no matter what. Okay. Start with 5A, because there's already a 1 up in that top left corner. But you ain't done. You don't come out of Matrix Town until you have reduced row echelon form. 1's down the diagonal, everything else 0s. Right. That's what I thought. It's big. there is a lot of moving parts here. What is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 14, 16. I'm exhausted, but I'm counting at least 24 individual arithmetic calculations within solving these. That's a lot of places to make just a dumb mistake. Yeah?
-3, and then add 6.
Okay. Row 2, 3 of those. This one, 9, 9, yes. Row 2, 3 of those. -1, yes. Okay. Times -3, -3, -27. Row 3 minus 2 row 1s. 2 of those is 3 minus 2 of those is 1 minus -6. Because you're subtracting 14. Okay. Owen is one of the most attention to detail guys in here, and got him with a negative. Like, there is so many places you can goof on these. You just gotta slow down and watch.
What did I do wrong?
Ooh.
I tried to do a 2-in-1 and not a big one.
Okay, that one's good. I think that's good. -2 row 1s. -2, so 5, -2, 1, 5. Okay. You can try to do your double dose. Okay, so +2 of those, check. Check. 2 of those, 27, or 18, 7, 25. Okay.
But then I got all zeros. Or did I don't know.
1 minus 3 zeros is not 0.
What?
Row 3
Minus.
minus 3 row 2s is still 1. Yep.
So I was there.
Yep, and that's just it. This is a different way to do systems, so you can be contained within an area, but it does involve more mental math. That's also why we're, not going to spend a boatload of time on it. But you have to see this before you go on to whatever your next class is, because this is actually an Algebra 2 thing. This is another one of those concepts, solving 3 variable systems by matrices. Should be in Algebra 2. Traditionally in this school we have not. They've left it for PreCalc. He's sensing a pattern here. I've got to show you this before you head onwards, because I really don't want any of you to go on to a college math class or into calc or whatever your jam is, and they start talking about matrices and you're like, whoa, 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 where'd all the letters go? Okay, we got to at least show you this and work with it. Get some practice.
Oh, that's what I got.
Uh-oh. -3 of those. If you're subtracting 3 of these, that's -27, -27, and -6 is -33. It's little stuff. Okay? And this is why we write the directions next to every one of the rows, because if I don't write the directions, no one else can follow the work. You can't follow your own work.
I'm confused how you get that. Like get rid of that.
I would say
Just times it by
row
2.
3 minus 2 row 2s.
Okay.
Yep. Move you over. There we go. I'm betting most of us at least have our first step the same. Row 2 plus 3 row 1s. 3 of these and add it, gone. 3 of these, 6, add it, -1. 3 of these, -9, and add it, gone. 3 of these, 21, and add it, 9. I need to get rid of a 2 with a 1. I'm going to say row 3 minus 2 row 1s. Times the -2 and add it, gone. Times the -2 is -4, add it. Times the -2 is 6, and add it. Times the -2 is -14, and add it. And when I first did this, I actually goofed a negative there in my head myself, and I ended up with a -52 over there instead of -33. And that domino affected me, because I missed a negative. 1, 2, -3, 7. Okay, now I have this value can be used to knock out these two. See how we're working across like column by column by column? I can do it that way. I could also use this guy to knock out that one. You have a choice. But if you have a pattern to how you do it, then the pattern will see you through because it takes that choice away. It's like a heuristic. You know, when in doubt, draw it out. Okay, those kinds of things, rule of thumb, is a heuristic. They're ways to help us make the tough decision. So I'm going to take this, double it, smack it over here. So I'm going to say row 1 plus 2 row 2s. Remember, I'm always referring to the previous matrix. So 2 of these and added is still a 1. 2 of these and added is bye-bye. 2 of these and added is still a -3. 2 of these, 18, and add it, 25. If I want to get rid of this guy, I'm going to take it times a -3 instead. So we'll say row 3 minus 3 row 2s. Times the -3 and add it is still a 0. Times the -3 and add it, bye-bye. Times the -3 and add it, still a 1. Times the -3, -27, and add it, -33. Now remember how I want 1s on the diagonal? That's a -1. So I use every available row and every available operation that I can. While I'm here, how about I just say negative row 2? Because now it's 0, +1, 0, -9. Okay? While I'm here, I'll just take care of it. And then the only thing left in my way is that guy. So a single operation remains. I'll say row 1 plus 3 row 3s. There you go. Words are hard. 1, 0. Take this times a 3 and add it. Bye-bye. Take this times a 3 is negative 99. Plus 25 is negative 74. And the other ones we don't touch. Okay? 3 steps, or 3 matrices with a lot of steps built into them. It enables us to do a large amount of work in a small area, in a very organized manner, which helps as these get bigger and nastier. Okay. I know these are tough. Again.
Get rid of, like, are we just supposed to do it with that there, or are we supposed to get rid of that?
Well, remember that you have a choice of moving entire rows, too.
But is this okay? Like, I just was doing it with the floor, but I don't know how to get rid of that later.
No, you did 2 different ways to get rid of it. Then maybe later in the problem you just end up having to divide by 4. Here. It's double-double elimination. This is like not just magical Christmas land, but your other family's Jewish, so you also get Hanukkah. Like, you get presents for like 3 weeks straight. Yeah, this one comes out real nice. that's a good size. We like those ones. Thank you. Okay, we'll focus in here because we know that part's right. Got our double elimination there. You negated. Oh, okay, you did that. Okay, so you just rewrote it, just double checking signs on the original. Cool. All right, negative or minus.
I made it negative because I wanted to make them.
Oh, but you said row 2. That's why I was confused.
Yeah,
because now it's your row 1.
But then I switched it back to
Okay.
row 1 again. So it's
Okay.
not really-
So row 1 plus 4. Row 2. You always refer to the last one. So plus 4 of those, plus 4 of those, plus 4 of those, plus 4 of those. Check. Row 3, 2 of those. As the mechanic is prone to saying, well, there's your problem. Okay, right here, I believe you meant row 3 minus 2 row 2s.
Row 3.
Oh, you're using this one. God dang it. Okay.
I don't like that. But then when I rewrite it, I just feel like I should leave it how it was.
Okay. So 2 of these, 2 of those, check. 2 of those, check. 2 of those is -7. Right? -2 plus -5.
Yeah. Wait. Row 3. Yeah, -5.
Okay. It's very rare that anyone doing these is just completely bamboozled. It's more, why are there so many numbers? And it's getting lost in the matrix. There's just too much stuff going on that sometimes we're going to miss a negative here. We're going to say 3 plus 5 is 2 instead of 8 because we accidentally subtracted. It's going to be little arithmetic errors, not big conceptual errors. And that's the problem with efficiency, is efficiency demands detail. Okay? So write this out again. There we go. Right? Yeah. Okay. So yes, if right now I've got a 1 in this spot, but I normally like it to be up here, I can change that right now. When I initially write my matrix, I can instead say negative row 2, right out in the gate. And then put this up here as a 1, 2, 4, and 1. Swapping it with the current row 1, 4, 9, 16, and 2. 2, 4, 9, -5. Okay, so I can just start writing my matrix like that to make it look more like what I want as I'm solving these. Then, boop, I will use the 1 to knock out things below it. I can say row 2 minus 4 row 1s Times the negative 4 and add it, bye-bye. Times the negative 4 and add it, 1. Times the negative 4 and add it, bye-bye. Times the negative 4 and add it is negative 2. So we get that magical Christmas land again. They're not always like that. I can say row 3 minus 2 row 1s. Times the negative 2 and add it, bye-bye. Times the negative 2 and add it, bye-bye. Times the negative 2 and add it, 1. Okay, so it worked out nice here. And a negative 7. I'm not going to mess with row 1 now. I already did my piece with it. Now, said you can do most of these in 3 steps. Sometimes you got to go to 4, 5, 6. Sometimes you can cheat and go to 2. Notice that if I'm trying to use this to knock out the 2 above it, there's zeros to either side. Zeros will not affect other numbers. Notice that if I try to use this one to knock out the 4 above it, it will not affect the other numbers. There's zeros to the left of it. You can double shot. Okay? Double tap, pow, pow. Okay? Get the zombie. I'm going to do this in one shot by saying, and this is legal, any combination of multiplication and addition of rows, I can say row 1 minus 2 row 2s minus 4 row 3s. I can do that instead of doing it in 2 steps. Do you see how it would be 2 steps? Because there's zeros to the other side of them, I don't have to do it in 2 steps. I can one-shot it. So I'd say 2 minus 2 of these minus 4 of those is gone. 4 minus 2 of these minus 4 of those is gone. 1 minus 2 of these minus 4 of those is 33. And then don't touch the others. Now, I'll be honest, doing that's just kind of flexing. Like that's saying, look at me, I'm smart. It's not necessary. But if you see that, it is legal to do it. Additionally, so far we've just been adding 1 row together. It's possible that in this very first step, if you can combine all 3 of them to eliminate a row, to eliminate a value, that is legal. Because you can add any 2 rows together, you can multiply any row by a constant, you can add any multiples of rows together, as many as you feel like. Okay. So, I said so far these have all been nice. They've been magical Christmas land. Everything's worked out pretty good. This one doesn't. This one you're going to have to eliminate each one of them piece by piece. Every one of these so far has had a double elimination in them. This one will not. Cross out 1. We don't have to worry about little guys like that. We are going to do problems 2 and 3. And in problem 3, some of you are going to get frustrated because see how there's already zeros? But look at what's above them in every row and column. You're going to have to undo one of those zeros to get the ball rolling. But it is not possible to do this problem because of how those zeros are staggered without undoing at least one of the zeros. Sometimes you got to break the egg to make the omelet. Okay? I mean, yeah.
So, for the thing on, we can switch first row and then.
Absolutely. That is the first thing I would do, is I would start by saying negative row 3 and then row 1. Like, that's just how I would write the matrix.
I don't like the little tutorials, there's no matter where to put everything, it keeps me, kind of just like label it up there, there's like row 1 on the bottom, and then write it.
Yes, but 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 when you go to your next matrix, now that's row 1, 2, and 3.
Oh, I don't need to prefer
God, no. Like, that's the point of this, is at every stage of it, this is now row 1, 2, and 3. It's like when you say, this is my family, and then your folks have another kid. You don't say, this is my family and George. And then they have another kid, and you say, this is my family and George and Sally. Like, you don't do that. You don't keep referring back to the original. You just say, this is my family. Okay? I mean, unless you just really, really don't like George and Sally.
You ruined my life. He's like, I always dreamed of being a rock star. He's like, you'll always be a rock star. I mean, you ruined my life.
That makes so much more sense now. That's row 1, not row 3. Oh, I just love that. That brings me so much joy.
Okay, there it is. But this is what I mean by keep at it with the questions of clarification. I have to say things 13 different ways for it to click into place for everyone.
I think I already messed this up, and I didn't have a step. That looks wrong.
Okay. So you
Just on this one.
You
first,
rewrote.
row 2. Yeah.
double check that our signs are all good.
So I
Check,
did
check,
this.
check, check, check.
Doesn't that seem weird? Look at the numbers.
So?
I'm not liking it.
Oh, wait till they get to
Why
be
can't it
fractions.
be
The
all
look,
the numbers?
the look of terror on Holly's face when I said, "Wait till they're fractions."
I think I got this.
Holly, if you ever see fractions, don't deal with them. Just multiply by the LCD,
Oh.
so that you don't have to deal with fractions. Then you just deal with big numbers instead of fractions.
I like that better.
You'll end up with fractions again.
Your answers will be fractions, but the coefficient matrix that you're working with will be fine.
No, I'm so.
Keep at it. I know this is tough, but you got this. And that's another thing too, is as we go through these, I am gonna show you where the magic button is, so you can check your answers. Every year there's students who try to do the first like 2 steps and then just kind of BS some numbers in between and then write the last step and make it look like they did the problem. I will take full points off for that. Full points off. We're talking like 10 off out of 30 on a test. I would much rather that you stumbled a little bit, ran it all the way to the end zone, knowing that those numbers ain't right, on your own steam. Because 9 times out of 10, you missed a negative somewhere. I give you 9 out of 10 on that. Okay? You know what you're doing. Trust what you're doing. Don't just cheat it.
What is this? How do I do that?
Okay.
What's going on?
So now you have to do something like, that's a 2-variable system, right? 16 times this one, 13 times that one. Wouldn't 16 times this minus 13 times that
Yeah,
cancel out?
yeah. So you do like row 2 times 13 minus.
So I'd say like 2 row 13s minus, 13 row 2s minus 16 row 3s.
Okay.
Oh yeah, we gotta use some big kid numbers now.
Really, one shot is on one piece here.
Uh-huh. You about to get grammared, dude.
I seriously like can't add. I don't know what my essay test is, so.
Look at that piece over there.
Wait, what did I do?
Octave, lucid.
There's an old joke about that, about little Timmy learning plurals in elementary school,
I'm
and
referencing that skit.
eventually he just kind of breaks down and says, "It's a flock of moosin?" I don't. Yeah.
I would love that. I love that.
It's like going to the animals with the English.
I can't believe I haven't given up yet.
I think,
Wasn't Spanish and French every noun gendered? I mean, language is weird. Oh, I should like do this.
I don't know what to do.
Okay. I am going to do this 2 different ways. No. I'm going to show you the raw, I don't want to think. I'm just going to follow the pattern way first. Okay? Which is always eliminating them in that order, right? You knock out the x's, then the y, now you got z, so you can knock out the z's above it, going through that pattern. So if I start with that, then, first of all, everyone's cool with me writing the initial one like this. I swapped the rows, I negated row 1, or row 3 into row 1. So now, I start here, I'll say, row 2 plus 3 row 1s. Times 3 and add it. Bye. Times 3, negative 15, and add it. Times 3 and add it. Times 3, 57, and add it, 52. Check my mental math, it's been a raw week. Then I'll say row 3 minus 2 row 1s. Times the negative 2 and add it, bye. Times a negative 2 is 10 and add it. Times a negative 2 and add it. Times a negative 2 is negative 38. And add it is negative 41, negative 61. Check me before I proverbially wreck me. Check my first stage. My signs might be opposite of yours if you didn't negate row 1. Okay. Yo, this right here, this is negative 16y plus 7z is 52. 13y minus z is negative 61. Couldn't you eliminate these by doing 13 of this guy and 16 of that guy? So that's exactly what I'm going to do. Some of us might need to do that in 2 stages. Like, if you need to write another matrix where all you do is 16 row 3, and that's it. If that's all you want to do in preparation for plus 13 row 2s, okay, then you need that extra step to guide you. I'm saying it's not necessary. I can one-shot that. Might not be a bad idea to grab a calculator, though, and say 16 row 3s plus 13 row 2s. 16 of those, or 13 of those and 16 of those is still a 0. 13 of those and 16 of those will be a 0. 16 of these and 13 of those. So that's 7, 91, 91 minus 16, 85, 75. Wait for it. 16 of these and 13 of those. I don't want to do it. So, I'm going to grab a calculator. I'll say 16 of these plus 13 of those, just because I don't trust myself. And I get negative 300. I ain't going to touch anything else. 0, negative 16, 7, that's not a 0. 1, negative 5, 1, 19. And you say, how do I get that to be 1s? Well, funny we should mention that. That's 75 z's equals negative 300. Divide by 75, and if you don't want to write an entire other matrix for it, I can just do this. I can just kind of cheatify that. Right? It goes in there 4 times. So I'm just going to add the divide by 75 onto my directions on the side. Now, you see you got your 1 down that corner? Go hunting. Keep going. So what's that? 28, 75, 80. Oh yeah, that comes out clean. I would use row 1 minus row 3, just 1 minus 1. And use row 2 minus 7 row 3s. You see how row 2, I'm down to 0, number 0. So now I just divide, I'm good to go. Now, I can take this row times a negative 1/16, or divided by negative 16, to call this 1, and to call this negative 5. But do you see how I can just kind of sneak that in there? Then it's one last shot. I'll say row 1 plus 5 row 2s. 5 of these and add it, gone, gone. 5 of these is negative 25 and add it, negative 2. 0, 1, 0. 0, 0, 1. You so good to go. Okay. Now I said I would start with just the way that I keep going around the circle. Didn't this big number stage here kind of throw a little hitch into it? We'll see if you prefer this. Don't I also have a 1 or a negative 1 down in that bottom right corner? What if I just kind of left my middle column alone for a minute and said, I'm going to use this right now. Row 2 plus 7 row 3s. 0. 7 of these was 91. Adding on to here is that 75 again. Right? Yeah. Add that on, gone. 7 of these is negative 427 minus 52, 427, 377, 363. No. Help me out. Negative 427. Well, I know that's negative 427. I'm struggling with just basic addition here. I'm tired. Negative 427 plus 52. Thank you. I can't right now. Okay, I can still do row 1 minus row 3 right now. Negative 5 minus 13 is negative 18. Oh wait, plus. Add that, gone. Add that, negative 9 and 5, 42. Right, 52, 42, 42. You see how that opens things up? I didn't have to go to Nasty Number Town because now this is 1 and negative 5. Now I can take that 1 to eliminate these 2 and I'm good to go. I'll just have to negate my answers for the last row. So you're not stuck into having to do that loop the same way every time, you get choices. Now, speaking of choices, I decided that I would rather just kind of spend an extra day flushing out chapter 6 here instead of trying to do a really bad version of a speed run of 10 concepts on Monday. So tomorrow will be more of 6.1 into 6.2. Friday will be 6.2 into 6.4. That's 6.4, not 6.3. And then Monday we will finish out 6.4. Okay? We just won't touch 10 at all because now with our seniors gone, I'm pretty sure every one of you had the purple book, the new book for Algebra 2, which means that you should have seen arithmetic series and sequences, geometric sequences and series. You saw that stuff already. It's just formula plug and chug. So I'm willing to cut it entirely and just get an extra day of making sure we got this stuff. Okay? Tuesday is quiz. By popular vote, the final will be one day only. You get to choose whether you want to come in first block 24th or second block 25th, or if you want to reschedule it for any of those other times. If you are going to reschedule your test into not first block 24th or second block 25th, if you are rescheduling into any different block, you got to let me know ahead of time so that I can write it down. Okay? Stars are open blocks for everyone. Let you know on Friday afternoon, though, I have to go pick up my kid because even Kids Club is out of business by 1 o'clock. So I'm going to pick up my kid and come back here. Okay? But I'm only looking for you at one of those blocks. So if you just want to sleep in on Wednesday, get it done on Tuesday or Thursday, I'm fine with that. But if you're going to reschedule to not one of those two blocks, you got to let me know. Otherwise, I'll just expect you are showing up to one of those two blocks. You get your review and whatever you can fit on. Okay? Nothing else. It is not open notes. It's the review and everything you can cram on there because the question looks the exact same. Okay? Remember we got turn-in piles over here? The super stapler works. If you have not turned in chapter 4, I need those. If you have not turned in chapter 7, I need those. I will not get to them in the next 24 hours because I am focused on getting the senior stuff done.